Okie doke. So, pollution. Just getting myself sorted out here. Yeah. So, we're going to focus our discussion around something called the environmental Kuznets curve, or the environmental Kuznets curve hypothesis. And I'm going to claim that substitution between alternative inputs or alternative technologies is absolutely crucial to explaining trends in pollution. And the other thing that is absolutely crucial is that emission of pollution is linked to the use of natural resources. In other words, it's costly to pollute. Okay, if you want to emit carbon dioxide, you have to start by like digging up coal or pumping oil or whatever. This is crucial to understand. Okay, let's have a look at the notes. This is based on a publication in the European Economic Review from 2020 and other EKC literature. Okay, so what do the empirical observations tell us? So this is the EKC, right? The inverted U shape. That what we often see in specific circumstances, often for a given pollutant in a given country, but sometimes globally, as we see in the right-hand figure, we see that pollution emissions broadly track GDP growth up to a point, and then they fall steeply. And of course, there's some pollutants which are still going up, and then the question is, okay, are they exceptions, or will they just, have they not reached their peak yet? And of course, to answer that kind of question, and some pollutants are going up in some countries, whether they've come down in others. To answer the question of whether this is just exceptions or whether there's a general rule or whatever, we need a theoretical model. We need to understand what's going on, right? And that understanding is what we're going to get in this core lecture. The seminal work is by Grossman and Kruger, and there's basically a consensus in the empirical literature. There's strong support for the idea that when you plot a single pollutant, single country, in most cases, it'll often rise and later decline. Although not always, we don't always see the decline. But if we compare paths for the same pollutant across different countries, it's hard to find clear patterns. The turning point's not at a given time, it's not at some specific level of GDP. So it's tricky if we just sort of try to do econometrics and say, oh, we're looking for the turning point at some time or some level of GDP, or sort of reduced form econometric models, it's like super tricky. We need more theory, basically. Okay. And one of the reasons for the problem is that in the theory models, pollution has often been treated as an input. It should, as if it should be that the more we pollute, the more we can produce. And if we think that way, we end up in a dead end. Okay, it's super hard to explain the data. But actually, that is not the case. So pollution is a byproduct of other processes, right, which are costly. If we just think of this model, so we've got, we go back to our basic model from the sort of DHSS style stuff. Labor coming in, consumption coming out, and then we have a resource sector, like a mine or something. And we send some of our product or some of our labor, it doesn't matter, remember, into the mine, and the mine sends the resource into here, and now the resource flow, that is driving pollution. But it's costly. Pollution is linked to the use of the resource, but it's costly to use the resource. So in the absence of a pollution tax, pollution won't be infinite, right? You'll just use the profit maximizing amount of resource, private. Okay. So what happens in this setup, at low income, pollution damages are small, so now we're thinking in laissez-faire, as we saw from the DHSS variants, the models that we developed, not the original models. We saw that with technological progress, resource price is constant. You use more and more resource over time, you will get more and more pollution. You won't see an EKC. Okay. But in first best, if you tax pollution, you do. Because at low income, pollution damages are small, the constant extraction cost dominates, so the overall cost of burning resources is more or less constant, and natural resource use grows, pollution grows. But as income increases, willingness to pay to avoid this pollution increases, and if we're in first best, that you put a tax on that, and the cost of that tax starts over time to dominate the extraction cost of the resource. And at that point, the cost of using the resource, which is the sum of the tax and the extraction cost, starts to rise, which pushes the resource use down. And if you've got some alternative resource that is clean, you will switch to it at some point. And that's when we see dramatic shifts, when mechanism 2 kicks in. Okay. That is basically the story, and now we're going to get into doing the modeling. So I think this will be another very brief video because I'm going to stop it there.